So that's why these back of the chapter problems you guys need to pour your little hearts into. And why we're getting those that, oh, anybody else? Smash the door in the face. So I haven't, there might be a little multiple choice too, but mostly short answer. So that's what we're going to do today. Any other questions before we get started? So be prepared. What my plan was, and it's kind of open for you guys too, but I thought I would do kind of a buzz saw, is what I like to call it, through the PowerPoints to kind of refresh your minds, and then we can look at possibly some of the problems if you want to review. So if you have your problems with you, kind of have those ready. I think what I'll do is I'll buzzsaw through the chapter, and I'll pause for questions if you guys want me to slow down on something in particular. And then we will look at the problems at the back as well. Okay, I'm just going to jump right into chapter 2. Chapter 1 had kind of some intro stuff, but really most of the problems and everything were starting in chapter 2 anyway. So these look like some good multiple choice type problems, right? Opportunity cost, marginal analysis, Nash equilibrium. Who wants to give me a stab at Nash? A Nash equilibrium.
Neither party wants to change their decision.
Okay, and it would be like a choice set, right? A set of choices, or a solution, an answer, or a quantity, a price, right? It's something. So it's a situation or a choice combination such that neither party can basically make themselves better off. And that is a Nash equilibrium. So there's no incentive to change. So neither party wants to change their answer, taking as given what the other one has done. Okay. Comparative statics, Pareto efficiency. So what was the idea of Pareto efficiency?
Nobody can get better without making somebody worse off.
Good, yeah. Nobody can get better off without making somebody else worse off. So there's an improvement, if there is an improvement to be made such that you make that move and at least somebody's better off without making anybody else worse off, then that means your previous situation was inefficient and you should do that change. So Pareto efficiency says you can't make any move without making somebody else worse off. All right, and then these self-reinforcing changes we've seen like with the growth models and stuff, where they can kind of build on each other. All right, so opportunity cost. This stuff is all in your book and the PowerPoints. So again, I'm just going to kind of buzz through them. Stop me if you want me to say something on any particular topic, but we're just going to kind of review them as we go. Here we brought in building height with cost-benefit analysis. So here's the Nash equilibrium. Supply and demand, why is it equilibrium? Nobody has incentive to change. If we're not there, excess demand, excess supply. All right, so where'd we go here? This was our first introduction into a little location model, location choice. So we got lefty and righty, and they currently start off at 3 and 9. Is it a Nash equilibrium? No. And because somebody can make a move. What move would that be? More than 6, so move to the middle. So one deviation, and we talked about doing those incremental changes. So possibly on some of the homework problems and things, that you kind of show that by saying, if lefty moves to the middle, then righty just lost part of his market share. So now the market share changed from the shaded area here because lefty and righty, the consumers don't care, they're perfect substitutes of whoever they go to, and so they'd end up going to whoever's closest, and then eventually righty would want to pile up there too, and they're both located in the same spot. So pricing, if there's things in different areas that are desirable or less desirable, then wages and prices can adjust to accommodate that. So this was just on the analysis stuff, comparative statics, the external variables changing, new higher costs with regulation maybe. Price of fertilizer being an outside variable. So this was kind of bare bone basics. We've come a long way since here. Here's the Pareto stuff. Which allocation is the most fair? What's our idea of fairness for A, then B? What do we think about fairness in economics class? We don't give a damn about it. That's for politicians and real human beings to think about. In economics class, we might learn how to predict where we're going to go and why. And when I step off of my economics hat, I really still have it on, kind of. I might have an opinion about what I think is fair or a better way to allocate what somebody else thinks is fair. But a lot of times fairness is very subjective, right? So that's kind of the whole point of economics, brings this positive analysis to it rather than the subjective analysis to it.
But every point up there is Pareto efficient, right? As long as it equals 12, right?
Right, so that's the whole point of this. Efficiency versus equity. I thought there was maybe something behind there, but so can we make a move that makes somebody better off without making somebody worse off? No. So it's efficient, but somebody might look at that and then say, that's not fair, Abe has everything, right? So there is a distinction between efficiency and equity. And so the normative issue is the should. So we say in economics, we're going to examine that this is efficient. It just is what it is. Efficiency, as we defined it, it is what it is. Even as an economist, I might think, well, that doesn't seem very fair. I think it should be something else. But we can all have opinions about fairness, but that's a normative issue. And so that's where we shift that over to the political realm of, should there be something done where the government gets involved with creating a social safety net? Should money be taken from the rich and given to the poor, right? Those are all opinions across the board. And so the economist steps in and says, well, if you do it this way, if you take from Abe and give it to B with a income tax, that would be less efficient than taking from Abe with a consumption tax, a sales tax, right? So we can come up with different methods of, you want to take money from the rich and give to the poor. Wait, let's go to the economist to say, what would be the most efficient way to get that desired outcome, right? So that's kind of the two pools of places that the contribution that economists bring is more with the efficiency aspect, so that other people can judge equity, and then they can fight on Twitter and stuff, and Facebook and whatever, right? Let them do the fights. We're just going to kind of analyze it. Okay, questions or comments there? All right. So this again just kind of got back into defining efficiency. Some of the normative positive distinction. External costs, so I guess this was our first touch on a little externalities where we get some congestion, we get the 100 drivers, the value of the trip, does the driver actually have to pay for their Congestion, usually not, but we develop toll roads, and that gives incentive for people to take other roads. So bringing the pricing, the market mechanism back in might alleviate some of those problems. We'll get into that. We have a whole chapter kind of on traffic and buses and stuff. That's kind of fun. We'll dive a little deeper into that later. Okay, self-reinforcing changes. So this was our auto dealership of clustering, kind of our first introduction into the concept, where their profits are spread apart, not as much as if they go together. And so these agglomeration economies, through the various things we explore later in the chapter, can lead to the magic auto mile, where all of the auto dealerships are all piled up on top of each other up in Shawnee and Overland Park. All right, so that was chapter 2. So now, why don't you guys pull out your chapter 2 problems, just kind of review them in your mind. I suggest that you go back and do every single problem again and see if you can do it on your own without looking at your old work. That would be a great way to study for the test. So let's see, this is so there could be some problems. This would be a little bit more of a review. These might be multiple choice-ish type of problems, but I'll just tell you that most of your focus should be on the apply problems. Most of your focus should be on the apply problems. So you're going to have some other ones. So we had the tribe. So this was comparative advantage problem here, the cost of the expedition. I'll just kind of talk, but you guys go ahead and look and see if there's ones. The building height. So that was marginal analysis with building height. Median voter. Quiet house, noisy house.
Was the one with the bear the one we had a lot of trouble with?
Yeah, yep. That was the one where we weren't happy with the way that one was. So we did make comments on kind of making it right, but yeah, I won't throw something that was what I felt wrong or questionable on the test. So don't worry about. I'm not saying it wouldn't be on there. I mean, I might have put something that I felt was like on this problem where wasn't the thing that kind of screwed it up was the dash is faster if both wear shoes and neither wear shoes or something. I don't know. It was kind of weird the way that one was set up. So I'm saying it'd be good for you to review it, but I won't throw the exact same problem if it was one that we had kind of issues with. And pizzerias and food carts. That's 13. All right, seeing anything there as you review that you'd want to rehash a little bit? And I kind of forgot, we're going to jump to chapter 8 next. I did want to start with 8 since you guys just did that one, and then we'll come back and do these other ones. But so after we get done with chapter 2, we'll jump to 8.
Can you run over the Hungry Bear one again?
A hungry bear. So outrun a hungry bear. We got 2 campers. Dash and Slog are identical twins, so they have the same shoe size. Dash is a faster runner if both twins wear shoes, and 2, neither twin wears shoes. A person wearing shoes outruns the person without shoes. The bear will eat 1 camper along with any shoes worn by the victim. Describe the Nash Equilibrium. And so the thing that we stumbled on when we did that, so if you saw a problem like this, you know, I think setting up a little gain matrix wouldn't be a bad way to do it. But here with the wearing the shoes, it's like the other person was screwed. Like this was just, they had all the power, right? They were basically going to win no matter what, which meant they had a dominant strategy of either picking the shoes and the other person, it didn't matter, they were going to die. So that was kind of what we came up with. So if I rehashed a problem like this, you know, I would say make sure you can put it into the matrix and then be able to put the payoffs. And remember, I give partial credit too. So if you're able to kind of reason your way through it, that's why I'm saying you kind of the way to approach it would be to lay it out like that. And I can't remember, what was the author's answer to this? Neither wears shoes, or no, it wasn't neither wears shoes. It was
The answer for C was 0. I don't remember it.
the efficiency gained from the Nash Equilibrium, from switching to the Nash Equilibrium to the Pareto efficient outcome. Oh yeah, that's right. He was trying to set this up as a prisoner's dilemma, but it didn't really work very good. Yeah, because the payoffs didn't work that well. So what was your question? Oh, I just was asking what they said. What did he say up here for A? Describe the Nash Equilibrium in terms of the number of campers who wear shoes? Both wear shoes. But that wasn't even, well, it was obvious because he's going to wear the shoes because then the other guy would have the choice of wearing the shoes and he didn't. Okay. Is that good enough, Lawson? You just want to talk it through a little bit more? Okay. Anything else on this chapter 2?
Can you hit building height one more time?
Building height. Okay, so number 3, building height. Total revenue from the building is 5,400 times. Oh, this was the natural log, where ln is the natural log of, and h is the building height and floors. The total construction cost is that. Using a bit of calculus, the marginal benefit is this 5,400h, and the marginal cost is this. To satisfy the marginal principle, what's it going to be? So this is just marginal benefit equals marginal cost. So if you take the 5,400 divided over the h to solve for h, and then the marginal cost is 6h, so solve that problem for h. And then, I don't know, there might be the look of it, if it said to illustrate, but you know, it's either going to be this or this. If it was upward sloping, if this is flat, 6h, so one of them might be going up and one down, so just kind of map it out with height. Okay, and then what they didn't ask, to satisfy the marginal principle h star is this. It says illustrate, but I think what we talked about in class is it doesn't really ask it here, but you would just take that height. What was the answer?
30.
30. So you take 30, and then you could plug it into the total revenue function, and this is the cost function. So it's just 30 squared times 3 plus 1,000. That would be your total cost. And then your total revenue would be 5,400 times the natural log of 30, which you'd have to use your calculator to do the natural log of 30 times 5,400 and calculate the profits. So, I mean, he left it kind of general with, did he only give 20 or 30 as the answer for that one? Yeah, because he didn't really ask that part of it. But okay, anything else on this chapter? All right, so let's jump to chapter 8, which was due today, so that we can have those in the hopper as well. So chapter 8. Floor is open.
Can you look at 3 on the apply?
3 on the apply. All right, predicting wages and employment. In the city of Groveville, the equilibrium employment is 100,000 and the equilibrium wage is 100 per day. The wage elasticity of demand for labor is -1. The wage elasticity of supply is 5. Suppose the demand for labor increases by 18%. Illustrate the effects of the increase in labor demand on the urban market. Include the values for equilibrium wage and total employment. Okay, who's got an answer? Jonathan?
I didn't draw it, I used words, so somebody else.
Who's got a drawing? I saw Jacob. Why don't you come up? Jameson, you too, but let's see what Jacob's got there. Alright. I was gonna try to see if we can do it here, but let's let me blow it up. Okay.
There was an equation in the book that we used for one of the example problems we did that day. It had the supply, elasticity of supply, minus the elasticity of demand on the bottom, and the total percent change in, I forget what it was, listed on the problem. So you took that over the elasticities, which gave you 3%. And so the percent change in the number of workers is going to be your elasticity of supply, which is 5 times that percent you found, which is a 50% increase in the quantity of workers.
Okay, so yeah, I'd like to see your graph cleaned up a little bit. Oh, I lost him, okay. What is, so that's why I pulled this up here. So one thing was there was a demand shift, right?
Yeah.
So you should have that coming through like that. And what's this number? Anybody do that?
Yeah, 100 times the original.
Yeah, 118. So that's your 118. Just so that we have all the pieces of the puzzle. It didn't, I don't think the problem maybe the way it was worded had all that, but, and then we had the 3% bump, right? And so, yeah, this equation, certainly need to have that one down. So that was the one we used yesterday. So Lawson, does that, were you the one, no, Jonathan, who asked this? I lost track. Oh, it was Lawson, okay.
Yeah, it was me.
Does that answer your question?
Yeah.
Anybody else on this one? All right, thank you, Jacob. Ooh, applause. Okay, other people on this section, Jameson?
Can you do the 11 review? I just got confused on how they got number 3 for
All right.
the wage.
So 11 on the review. I'm putting it up there. There it is. Suppose, this one here. Suppose the wage elasticity of labor supply is 5 and the wage elasticity of labor demand is -2. A 21% increase in labor demand will do what to the equilibrium wage by this percent? Okay, so this is basically the same type of problem, right? I mean, same type of problem. So, so which part were you confused on, James?
The second, fill in the blank.
Oh, how much the equilibrium wage will increase? Okay. So what did you have? What did you guys have? So 21% increase in labor demand. What did you guys have for the impact? What was the answers basically for both of these? Increase. And that was for the first fill in the blank?
That's for the
Oh, that'll just increase the equilibrium. Okay, so that was fill in blank 1, fill in blank 2. Okay. So what's the formula in general? Since this is the second one on here.
Change in wage
Yeah,
equals
yeah.
percent change in demand
Not just-
over the elasticity of supply minus the elasticity of demand.
Okay. So from this one, we have a 21% increase in demand, labor demand. So we have a 21 upstairs. And then what are these elasticities?
Supply is
5 minus a minus 2 gives us 7. 21 divided by 7 equals 3. Does that make sense, Jason?
Yeah.
Okay. Anybody else? Other problems on chapter 8?
And you did 7 on the apply.
7 apply. Number 7, apply environmental policy. Okay, consider 2 cities, each of which initially experience 100 tons of pollution per day, 50 tons from each polluting firm. City T imposes a pollution tax resulting in an overall pollution reduction of 20% and a decrease in the equilibrium employment. City U implements a uniform reduction policy under which each firm cuts its pollution by 20%. Which city will experience a larger reduction in equilibrium employment? Ooh, that's kind of a fun one. So what did the answer key have?
You.
City U?
Yeah, city is gonna be hit for
All right. So, City U. And then, of course, this is the type of question you'll get on the test. Why? I need more than City U. So, what did you guys come up with as answers? How'd you justify City U?
So
You want to go, Jonathan? Okay.
what I said was a tax makes a firm pay for the amount of pollution it puts out so it can still pollute.
Okay.
And that a uniform reduction makes them automatically reduce the pollution, so they have to lower costs for the stuff because it's going to cost them more to not pollute as much.
Okay.
So they had to lose some workers and don't demand as many.
All right, so so basically the City U implements a uniform reduction policy under which each firm cuts its pollution by 20%. And which one's going to have the bigger reduction? So, what else? That wasn't too bad. I'm not saying that was wrong. What else did you guys say? Give me another answer. Yeah, Zeke.
City T's equilibrium employment went down, but wage is gonna go up, and most people are gonna, I'm confused why.
Okay, well, I think it'd be good to be able to analyze the tax in City T. So let's just kind of focus in on City T for a second. So City T imposes a pollution tax, resulting in an overall pollution reduction of 20%. And a decrease in the equilibrium employment. So it basically comes down to this U versus T with tax versus otherwise. So how does the tax work?
The tax lowers wages.
Okay, the tax is going to lower wages. So whenever we implement a tax, if we're in the supply curve of this product, right? So if we're doing pollution tax, I guess how is it being assessed? It's going to move us down to where both the consumers and the producers pay for the good, right? So we were here with this is with the tax, S2 tax. So now the consumers pay higher prices relative to what they were before. So higher prices for the good in the tax city. Does that happen the same way in the City U?
I just don't know.
I guess I'm not sure what a uniform reduction exactly means.
Yeah.
Yeah, what does it mean? What did you guys write?
Of the 20%, right?
What's that?
Like that, every single firm in city has to cut their pollution rate.
Yeah, I think that each one needs to cut it, and therefore then it will cut by that amount, right? So each one's being, I guess, punished similar. 2 cities, each of which have 100 tons of pollution per day, 50 tons from each. So what would 20% be of that? Let's see, 10% of 50 is 5, so 10 tons less is a 20% reduction, right? So we were at 50 times a 20% reduction gives me 10 units less, so that means we're at 40 each. Okay, and how about the tax? So City T imposes a pollution tax resulting in an overall pollution reduction of 20% and a decrease in equilibrium employment. So is it just the higher prices?
I mean, the tax puts some of the burden on the consumers, so the producers aren't having to foot the whole bill in CBT, but they are in CBT.
Yeah, I'm not sure I love this question, actually. So, because there's just not enough in it, and you're right, that we bear the burden with the price, so we've got the higher price here of the good with the tax. One thing is, where does this go? I think would be an interesting thing to talk about. What's that? What is this box? It's the tax revenue. So it is the tax revenue. What's the government doing with that? That doesn't really get talked about up there. What else might be going on with this problem? I think it brings up interesting things. I'm just saying, I think you could come up with some different things here. So that would be one of the things. Jacob?
Does this have to do with the,
Oh, go ahead, Lawson.
does this have to do with opportunity costs?
In what way? Everything has to do with opportunity costs. That sounds like a...
Well, rather than focusing time and effort to cut emissions, we can just pay the tax right out the gate and not have to worry about spending time on doing the other.
I mean, I'm not sure where you're going with the opportunity cost part of that, but so they are fundamentally different though, right? Because one affects the price pretty directly, gets shared by the consumers, but I'm not sold that the other method doesn't do something similar. So I saw another hand up though. Jacob, what was your comments? You don't have to respond to what I said.
Does it involve dead weight loss?
There is a dead weight loss too. So we've got this dead weight loss here with the tax. So this was before the problem, but here with the pollution, did they say it was killing people or not? Or did they just think it was bad?
They just don't like pollution.
They just don't like pollution, yeah. So it imposes a pollution tax. So I don't see that there was any study done that there was negative effects from the pollution. They just didn't want it, right? So maybe Mother Nature was absorbing the pollution just fine, and they just wanted to do less of it. So that's possible. But what happens when they do the 20% reduction? Talk to me in terms of the cost of the firms, the city for you. Todd.
I think the thing that they're trying to get you to say is that the demand side on you goes down because there's less there's less need for workers in the city because the firms aren't gonna wanna be in who they'd rather be in.
Okay.
And so then if you draw.
With this price effect, maybe.
Correct, and so then if you draw if you draw the new demand curve, then it's lower than.
And this is like the output market here. Remember that the other part of the story here would be the labor supply and labor demand going on here with the, oops, this is labor or workers, and this is wages, right? So that's the other part. This is the output market here, or whatever they're making that's making pollution. So now we've got some higher prices. But what happens when you're told you need to reduce your pollution by 20% to the company? Do they like that? Do they like being told that? Is that like no big deal? Oh, 20%, we just wave a wand and 20%'s gone. It costs money. So what happens graphically when a new regulation is imposed with 20% reduction? What happens in our supply-demand framework when the cost of production go up? Because presumably, in order to clean up the plant, it's not free. Price goes up. What happens to supply? It shifts also. So here, when we do it that way, the supply curve might start to look like what we got over here, right? So fundamentally, those two things could look differently. However, it's usually going to be more efficient to let a private company figure out how they're going to drop it by 20%. Some might invest in new machines, some might have more labor do it. You know, there might be different ways to do it. And so certainly I agree that the uniform reduction policy, if that's the policy that was going to be done, if I had to, just exactly what I was saying, I guess in the introduction a little bit, the economists can help pick out, you want 20%, here's one way to do it, tax, here's another way to do it with the uniform reduction. So allowing more freedom to pick what that's going to look like works. They get a higher price, but now we have less pollution. So what did we talk about with pollution effects over here on the labor market? Are they going to want to live there more or less? The city with the less pollution.
They'll want to live there more, but since the wages go down, isn't less going to be supplied?
Yeah, so there could be a wage effect, right? So is it, in both cases, would the labor supply curve move? Did we have the same impact either way?
Yeah.
City T imposes a pollution tax resulting in an overall pollution reduction of 20% and a decrease in employment. City U does the same thing, in which each firm cuts its pollution by 20%, which will experience a larger reduction in equilibrium employment. So which one's going to be a bigger effect? And that's where I think these taxes and the quantities would change, because now to live in that city, I have higher prices, which might be here, but also what is going to be the demand effect. And I think the business is going to have less of an effect with the uniform reduction. So if we had an equal shift here, because people want to live in a 20% less pollution place, we got that in either place, but now the demand effect is going to be bigger in the city T as opposed to city U. Okay, so that was just to kind of point it back to that was like the last thing we talked about. Let me just put this picture up here. It was the size of the shift. This one was a little bit different because we were looking at that tax in regard to the size of the shift. So the demand with the tax, what's going to happen is going to be a little bit different size. Okay. Other questions on this one? Yeah.
5, supply.
Football team. Consider the results of a consultant report on the economic effects of moving the Raiders to Sacramento, who are now in Las Vegas. The consultant estimated that the team would increase total spending in Sacramento economy by 61.6 million, as computed by this spending multiplier, the final change in spending, and then we've got the amount and the multiplier. So $40 times 700 times 2.2 is the multiplier, 61 million. So we waved our economic wand. So S was the spending per fan, N is the number of fans attending the game, M is the average spending multiplier for the Sacramento economy. Define an outsider as a person who lives outside Sacramento, insider who lives inside. The consultant's calculation overstates or understates? Overstates because, did the author not give you guys the because, I'm guessing? Or did he give a little
It
bit?
says some are insiders and some players are outsiders.
Okay. So what did you guys comment on that?
Most of your fans already live in Sacramento.
Okay.
Live in Sacramento, so you've already got that revenue.
Yeah, a little bit more on that. Well, how do you have that revenue?
They're already,
Oh, what they're spending at the stadium.
yeah. It's just being spent, it's just a business.
Yeah, depending on if they substitute what they would have done outside spending versus inside spending, then you might start to have an argument that they're, instead of buying stuff in the neighboring town, they're buying it here, if that went on. What else? There's some other comments you can make from the book and stuff too. Zeke?
The players are spending their millions of dollars in town, particularly living outside of Sacramento.
Okay, good. So they were the outsiders spending their money elsewhere. John?
Which that makes it so the multiplier doesn't really have anything because the millions of dollars aren't getting spent in that city.
Right. The other thing that I didn't hear you guys say that's an important one is that the insiders are substituting for the game. So instead of going out to movies at the local movie theater, they're going to the game. So there's no gain there at all. It's just a substitution effect for the insiders as well. Right? So we got that insider substitution that will play a role. I kind of wanted to bring this up. I won't take too much time, I promise, but it's kind of cool. So my buddies who I went to graduate school got a journal article published. Some of you might have heard me say this before. So the Minnesota Vikings, and I'm a Minnesotan, and one of my graduate school buddies was Minnesotan too. The Vikes were going to potentially leave Minnesota. And so, of course, people are like, oh, we can't leave Minnesota, blah, blah, blah. Well, that was a real threat, and so they were able to get some data on they did some surveys of how much would you be willing to spend to keep the Vikings in Minnesota. And so they got this data back, and what's kind of cool here is that you might not be a fan spending money at the stadium, but you have a heritage in Minnesota, and you like the purple, and maybe you watch them on TV, or you just like the Vikings being part of Minnesota, right? It's kind of a tribal effect is what economists call it. And so they asked, and they found out that their results were that $571 on average. So the Minnesotans were willing to pay that on average. Multiplying that times 1.3 million households in Minnesota said that they valued them at about $750 million. The problem is, I don't know if you guys have seen that sweet stadium, it was Super Bowl a couple years ago. That was over $1 billion. So, but they at least were able to contribute out this whole thing of should the city subsidize a stadium or not? You know, is there kind of the goodwill? So that was kind of a interesting study. They got that published, and that was the effect. Ultimately, the Minnesota government ended up giving them $500 million. Yeah, I can't remember where that was stated on here, but anyway, that's what they gave was 500. Oh, there we go. I just didn't scroll down. So that is economics in action with stadiums, and again, here, what's interesting is it showed that the fans didn't even value a new stadium at what the new stadium would cost. So certainly we shouldn't be buying the whole stadium based on some of those studies. Okay, other questions on that one? Yeah, I think you guys addressed all of them. They were here on the book, the local substitution, crowding out. This one I don't think you guys specifically said. So a mega event causes crowding out. For example, hotels may be filled with fans rather than tourists. So if football fans are coming and now a tourist who would have been coming to my town and spend money can't because the hotel's booked. That's what that one's getting at. Crowding out, and then the leakage we talked about. All right, any other questions for 8? Okay, well that was the main thing with the elasticities and stuff, so let's go back to the PowerPoints here. All right, so this was the comparative advantage model. So with these, just look at the trade-offs. I like to always put it in equation goggles. So Stitch can do 12 shoes or 2 milk. So I look at that and just go, for Stitch, it's 12 shoes equals 2 milk, right? So that's the trade-offs for Stitch. That means the opportunity cost of a shoe is 1/6 of a milk, or vice versa, and it's 6. So that was the basic comparative advantage stuff. I think this is our first major talk on economies of scale, which we continue to do. All right, so then we have this fun model here. So we had cost of gallons of milk, in terms of gallons of milk, capital cost of living, which then led to our areas for the martini glass. Let me just open it up to you. Martini glass questions. You need to know the martini glass for the
We
test.
just do
Do a problem? Okay. Let's just do one of the problems after we burn through the PowerPoints. We can just go review one or two. I think there was at least a couple martini glass ones. But for everybody here, what is the sides?
distance.
The sides of the martini glass.
Transportation cost.
Transportation costs. So remember, whenever we're in this space, you've got 2 dimensions to be mindful of. Distance to the factory, but if we're up here, then that means that correlates with something over here. And so it's the transaction cost. So if I move a mile from the factory, then it was 0.1 of a gallon of milk was the cost, was the transportation cost. The further I live, we go out to 7. What was this top, the lid of the martini glass?
How much it costs to do whatever product you're making.
Okay, the cost of the product, whatever you're doing, where? At home. So that's your opportunity cost. Getting back to that concept, that opportunity cost is pretty heavy in this chapter. So it's saying I can make it myself at home for 1. So if I'm going to buy it from you, you need to be able to provide it to me at something cheaper than what I can do myself. And so that then establishes the market area. The factory, due to economies of scale, at the factory and machines and innovation, they can make that for 0.3. It costs you 1 to do it at home. And so now you can buy, no matter where you live in this market area, that means you'll be able to buy it from the factory cheaper than what you can do yourself. That's basically the whole thing in a nutshell. Questions there? Okay, so a little thing, a little history. What happens when it's getting wider? What's happening to transportation costs?
Lower.
They're getting lower, right? So as it fans out, it's getting lower or it's getting higher. The stem is the cost at the factory, so that could go up or down maybe over time. So some of the questions look at that. Okay, so let's go ahead and look at problems. You got one, Bryce, since you brought it up in here. Chapter 3. So I think number 5 is a martini glass, right?
There was one of them that was like a teleporter or something.
Yeah, the teleporter one was matter and a matter transmitter, number 7, I think, right? Yeah, that was one. Did you find one, Bryce, or
That's odd now.
this one? All right, so let's do this one here. Consider the effects of a new matter transmitter. If I can get some focus. You guys probably have your books in front of you anyway, so maybe it doesn't. All right, let me see if I can. Is this the focus button? Oh, is that good? Does that work? Wow. Oh, now I've ruined it. Okay. What's this button do? That like flips it around though. Yeah, that's not good. I don't know if it's because it's autofocus that it just, what's this button? Oh, there we go, that is it, the blue, okay. But now it looks weird. What's going on? Light? Oh well, all right. Consider the effects of new matter transmitter. The matter transmitter instantly transports goods, but not people from the factory to any consumer up to 12 miles away. With a zero marginal cost of transport. The hourly rental of the transmitter is 0.1, so we did that little adjustment. Using this as a starting point, what's it going to look like? So I don't know if this is the best one, I guess, for maybe what you were asking, Bryce, but so we ended up getting the goalpost on this one. So we had the original looking something like this with the 0.1, or this was 0.3, and so now we have to pay for the matter transmitter, but we can go all the way out to the area at the same cost. Did it increase our market area? I can't remember. Oh, up to 12 miles away. I don't know if 12 was the original starting place or not. Anything else? I guess the drama was the upside down utility one.
Oh yeah, those upside down martini glasses.
You want me to do that, or just review it, or?
Yeah, I can just kind of go over it.
Okay, so this one has a little bit more of the math, I think, to it. So we've got the drama, either live performances or broadcast. After accounting for prices, the utility of a live performance is 24 compared to 6 for televised performance. There are scale economies in the production of live drama, which provided at the performance venue. Travel cost is 2 units of happiness, utils per round trip. Illustrate the market area for the performance. So the market, the live performance is the most desirable. So how would you draw that?
Well, the stem is 6, and then it goes on a slope of 2.
So what are we measuring up here?
Utils.
Utils. And what are we measuring here?
Distance.
Distance. So we can come from any direction, so distance 0 somewhere, right? All right, what's the height here? So we've got televised performance gives me 6. So then which one's the alternative to live?
Televised.
The televised. So at a unit of 6 height, that kind of gives us the top of the martini glass, but the martini glass is inverted, right? That was kind of the difference here. And so now if we live by the thing, we can get 24. And now what?
Goes at a slope of 2.
Slope of 2, so where do we end up? Down 2 over 1. So down 2 to 22. And now we've gone 1. So you could sit here and plug and chug it. Or what?
Just do 9 miles.
Divided by what? What are we trying to do?
24 minus 6
24 minus 6 divided
divided by 2.
by 2. So what do we get? 18 divided by 2 equals 9. So is your answer 9?
That's where you're indifferent, is at 9 miles.
Okay, so we're at 9 miles, so this is like, comes down here to whatever, this is at 9. So your answer's 9?
9 is where you are.
For one way.
Include a value for the radius of the market area.
So it's, the radius is 9.
Radius would be 9, market area would be 18. So if we look at the full, because you can be over here too. So, you know, you could be fun with a problem like this and say, suppose there is a river with no bridge here at, you know, at mile marker 6. And then your market area might be truncated over this direction. Just to be fun, you could throw something like that in. Would I ever do that to you on the test? Okay, just thought I'd bring that up. Okay. Anything else on this chapter? All right, what's next here? What is that? That's chapter 3. Chapter 4. So agglomeration, sharing inputs, tapping a common labor pool, improving skill matching, sharing knowledge. What's that a picture of? Keep coming. What else is it showing? Just given the shape of the long run average cost curve, or that section of it.
Economies of scale.
Good, economies of scale. So you might be asked economies of scale, that's it, right? So as we increase the scale of production, long run average costs are falling. Does that happen forever? No, it's probably gonna bottom out and then maybe even go up with diseconomies of scale. Okay, common labor pool. This was a fun one. So let's talk about the tips and tricks here. So we have a 50-50 shot. I think the next slide kind of gets into the details here. So you're hopefully going to get the 144 if they stick around, but there's a 50% chance of failure, which means you're going to have a switch cost to a different job and bring you down to 100. So how do you calculate the certainty equivalent? Weighted average? Tell me how you calculate it. Let's walk through, instead of just weighted average, tell me how you walk through this one. McKenna, is that just brushing your hair back, or? Gotta be careful when you're trying to do the eyes there. So, McKenna, I'm gonna stick with you for a second here. So, how happy am I if I get paid 144 bucks? Using this model. What's my level of happiness? 12. So 12 utils is what we've been using for 12 units of happiness. Why is this thing shaped the way it is? Why does it look like that?
Money can't buy happiness.
Money can't buy happiness. Law of diminishing marginal utility, or diminishing, this is kind of related to diminishing returns, but we have this utility function that's shaped like that. So if I have less money, what's my utility level, McKenna? If I'm at 100? 10. What's the percent chance that I'll get 144? What's the shot? What's my shot that I'm going to get it? It's all up here. Just want to kind of get you going down the track here. What's my percent chance of actually earning 144? How much? 50, right? First line up there, 50%. And so what's my shot of getting 100? Loud. 50. So what's 50% of 100? 50, and 50% of 144. That's tougher one, isn't it? Okay, but now that's not actually what, so that's, I wanted to point you down that path because that is an expected value, but it's an expected value of who? Of a 50% chance of getting 50 and a 50% chance of getting 144. By the way, what's the answer to that one? What's 50% of 144? 70 would be 140, so 72? 72 plus 50 is 122. So you have a 50-50 shot of getting one of these, but whose shot is that? Who's the payer of the income? The company. So they have an expected wage of paying 122. That was part of the story that kind of comes in later. So now, the way this story works to figure out the certainty equivalent, we're trying to find the certainty equivalent for you. You have a 50-50 shot of having 12 units of happiness or 10, so you have an expected happiness level of 11. All right, so that's where this thing starts off with your expected utility you have to calculate is 11. And so now, what is the amount that you would be willing to accept if you could to get 10? Now you work yourself backwards and say, oh, if I knew for sure I was getting 121, then I would do it. That would be beneficial compared to an uncertain 122, right? So I'm certain, I would rather have this with certainty to get my 11 units of happiness with certainty. That's why we call it the certainty equivalent. So 121 is the value to the employee that they would be willing to accept because that will give them that value with certainty. That means the employer is kind of getting a good deal because they're going to be able to pay 121 with certainty by living in the cluster, by the way. That's ultimately where we come back to this with, right? And they would have had 122 if they were located separately. All right, so this is the whole thing about the common labor pool. So the benefit to the employer is that they're paying less in expected value than what they'd have to pay. The employee is happy because they are risk averse and they'd rather take a little bit of a cut knowing that they'll get 121 with certainty rather than uncertain. You've got a 50 shot, you're gambling here, right? You're either going to make 100 or you're going to make 144. And so they would rather not take that gamble and take the certainty equivalent. Okay, questions or comments there? All right, so then that gave us the basically the reason or the value of having a common labor pool and firms clustering. Okay, skill matching. So we have the wheel on a unit basis, and it's just showing that having a bigger cluster allows there to be smaller gaps that they have to fill. So there's more people to fill the right position. And then those models that we did translate that into money, because if it costs $30 to train somebody, then it's better if they're a closer match than if they're further away. All right, so that was our little equation for the mismatch thing. And this one was thinking about the equilibrium number of firms. So we have prop costs going down because of economies of scale in Hollywood. The more people are using them, the cheaper the prop costs, but at the same time, labor costs are going up with congestion and the other things in the city, the cost of the land, the rent, all of that thing. So their total cost is up here, and now that means there's going to be incentives for firms to cluster. For a while, profits are going to go up. When are they going to quit clustering? Well, when it's equivalent to what they could do by themselves. If they were in isolation, they could earn 10, but now we're going to have a cluster of 5 firms. But the long run equilibrium, the profits are equalized, like what we see in any competitive setting, right? That's one of our assumptions, or not assumptions, outcomes of perfect competition. Okie dokers. I think that pretty much brings this to a close. Yeah, we just looked at some clusters, no big deal. You're not gonna have to know those. I don't want you to go memorize these percentages or anything for the test. Not worried about that. All right. Any questions on chapter 4 problems?
Number 1 apply.
Number 1 apply?
Yeah.
Okay, I don't know why we get this funky light now. I don't know what I did, but that still doesn't matter. The total cost of producing each one, we're accused the number of products being tested, the price of the product equals the average cost. Each corporation region produces 1 test per year. All other inputs are ubiquitous, available everywhere. Suppose that the 5 corporations initially distribute uniformly with 1 corporation in each city. Is it a Nash equilibrium? And demonstrate. All right, so what was the gist of the story with this one?
They want a cluster.
They're going to want a cluster was the kind of the final outcome. How do we do the Nash test though? Like how would you show that on a test? Demonstrate a suitable, this is what I was talking about before. Not all you guys did this with your problems, a unilateral deviation. Jacob? So if they make a move, what happened to their cost? It went down, right? So by moving together, they end up making themselves better off, so then other people would want to do that, and we end up all 5 being in the same spot. And off the top of my head, I'm thinking 30 or something. Well, you guys probably have it in front of you.
Price is 22.
Price was 22. And so one of the other things here is with the competitive assumption, price equals the average cost. So whatever the cost is what the price is, because the price is equal to average total cost. Okay. Any other ones on here for a quick little buzz through? Hopefully you guys will be able to go back through. We did review them. The recordings you've been sent the recordings, so we did review those questions before, so you can go back and do that as well. Let's buzz through the last few chapters just to give you that exposure, and then we'll call it a day. So this is chapter 5. Okay, so this was our weight gaining, weight losing. I think this is pretty simple once we all got it right. So you just have to know which one's the input source, which one's the output source. And so to minimize cost, that's where you're going to locate. And then you'll have different rates of cost that we did with different solutions. So those problems I think went pretty good for you guys. We didn't go over that a lot. Okay, what's the trick with the median?
It'll always end up in the middle.
It's always the middle. So, but the median, the way you determine the median, remember, is 2 plus 8, there's 11, 9, 10. So where's the median? We've got 10 to this side, 10 to this side. So with an odd number, you're right on there. With an even number, you're right there. So in kind of splitting them. So the median's always the middle spot, and then it just turns out that that's going to be the one that would minimize your travel expenses. Even if it looked like this one turned out to be D. And then that was the other weight gainer where it was best to be at the port. All right, chapter 6, monopolistic competition. So this was kind of the linchpin for a couple problems, right? So in the long run, no economic profit, and so the tangent, the demand curve ends up being tangent to the average cost curve. And then this was the per capita demand. So whether we have operas and brain surgeons. So in the big city, we have a bunch of things, a couple other offshoots. All right, easy peasy. Chapter 7 we just did. I don't know if, do you want me to buzz through 7? I guess I have 2 minutes left. Might as well buzz through it, I guess we got time. Oh, this is important with the utility curve. So measuring utility, turn it into dollars, city size. Utility eventually goes down due to congestion. So shrinking or growing, utility goes up, less congestion. If you're growing, it gets worse. So it's possible for cities to be larger. The author uses too large because the maximum would be over here. But this is sustainable in terms of Nash equilibrium. You don't have incentive to move elsewhere with other choices. So there's the small, there's the medium, there's equilibrium. Utility is equalized across the small, medium, and large cities. Rank size rule. So the only thing you can bring tomorrow is that formula. So only the formula, so no words, no extra diagrams, no graphs. I'll allow you to have a formula sheet, which means formula only. Is anybody unclear with that? Anything on your sheet should be something like this, not rank, like R-A-N-K. You'll have to memorize that the R stands for rank. Am I clear with all that? Total cost, TC equal, whatever, if you want to do average total cost or something, but just the bare bones formula. Nate will be going around, and if you have anything other than that, then he's been instructed to take it away from you. So half the battle is you, and it has to be handwritten. So handwritten in your own writing for the formula sheet. Okay, I think that's pretty much it. Was the rank size rule for the innovation. We talked about the movement. All right. My flight's been canceled twice, but I'm still planning on going. So tomorrow sometime though, rather than shortly.